So in this video we're going to be creating Adhering Suzy, or otherwise known as Octo Battery. So in the original game, it's basically a robot that travels along the same path, and the eye opens and the eye closes. And not much else to it. So now in ours, let's take a look at that. So I have 3 in the scene. Here's the first one. And so the way it works is there's a raycast that gets projected out and looking for the ground layer. And once it finds the ground layer, it basically will stop moving. And that's when it goes to sleep, and when it leaves or wakes back up, then the eye opens, and etc. etc. So now let's go and check out the other one. So that one's traveling horizontal. So let's go look at the one that's going vertical. Which is right there. And this one's basically the same, except it's vertical, projects out a raycast, looks for colliding with the ground layer, and once it collides, it stops moving. So then if we take a look at this one over here, this one is invincible, so I'll die. So this one is actually not using a raycast. It actually moves between 2 points, so it can go super fast and still keep the precision. However, with the raycast colliding with the ground layer, there is a chance that it will move into the ground. So what I ended up doing was if it goes above a certain threshold, then it slows down before it hits the ground. So it's kind of like a little bit of a workaround. But this one is my preferred choice, where it just moves between the 2 points because it doesn't depend on any layers. And all you gotta do is just set the points that it's going to move between. You can have it go super fast and still hit the exact same spot each time. So let's start working on it, and we're going to get started. Alright, we're back. Previous project is open. Number 32 was the last one on creating the stage select screen. So if you've been following along, open up your project. If you're new to the series, then you have a lot of stuff before this one that you might want to review first. Because when we're creating the enemies, I have some scripts that are already involved that you're not going to have access to. But you can go get them. There's a link to my GitHub in the description of the video, so you can go and see all the project assets and everything up on there. But you're going to need the graphic for basically the enemy controller script, and some other stuff, audio clips, things like that. So we're going to move this out of the way. And first thing we're going to do is we're going to switch it over to the main scene, because that's where all the action happens. And what we're going to do is we're just going to disable all these existing enemies so we don't get distracted with the one that we're working on. So in the graphics folder, there is the file that we've been using for the enemies called enemies. We're going to open that up. Our Suzy is actually here. Suzy comes in 2 colors. There's red, and then there's blue, and then there's 3 frames for the animation. So the eye closed midway and then all the way open. So this is, when you go, this sequence is basically eye opening when the movement starts, and when it collides, to stop movement, it basically goes in reverse. So open, half open, closed. So we're going to end up creating 2 animations for this, for the 2 movement, for the wake up and the sleep, and about 4 total because we have 2 different colors. So first thing we're going to do is get all these images. So what you're going to do is you're just going to draw a square around all 6 of them. You can name them whatever you want. Your pivot's going to stay in the center, and you're going to you can just name it like red 1, red 2, red 3, blue 1, blue 2, blue 3, etc. Okay, so I named this one Adhering Suzy red 1. Red, same thing, red 2, red 3. This one is blue 1, blue 2, and then blue 3. So those are the graphics. And so then we're going to create the game object. So I run out of room here, so what I'm going to do is I'm going to hit the plus sign here and create an empty. And I'm going to reset the transform. And I'm going to call it Adhering Suzy. And it's going to sit on my enemy tag and my enemy layer. And the scale is going to be 1.5 on the X and the Y. And then what we're going to do is we're going to go to the scripts, enemies, and then we're going to drag on the enemy controller script. And what we're also going to do, since we're in there, we're going to right click inside the scripts folder. We're going to right click, create new C# script, and we're going to call it Adhering Suzy controller. And then we're going to add that onto our enemy too. We're going to add the code in a bit. So now that that's done, and then we're going to create a child on Suzy, and we're going to call it hitbox. And on the hitbox, we're going to add a component. We're going to add a box collider 2D, but it's going to be a trigger. All right, so now we're going to fill in the properties of Suzy. So we're going to skip the animator for right now. The box collider, you can't really tell. Let me bring this over so you can see what's going on. Can't do anything with the box collider yet because we're going to add on the graphics. So go down to the sprite render area, and then we're going to expand our enemies in the graphics folder, and we're just going to put the Suzy blue 1 on there, so the eyeball closed. So there. And then what we're going to do is change the layer order to 10. So there's our Suzy right there. So now with our box collider, to bring it in 1 pixel around, well, first you can reset the transform or reset the box collider, and it'll bring it around there. But we're going to bring it in 1 pixel around, so we're going to change that 0.16 to 0.14. So you can see there it is in 1 pixel around, and this other green box here has to do with the hit box, so we're just going to put the same dimensions, 0.14 for the X and the Y size. So there, now it's all good. So then if we go back over to Suzy, so the box collider is done. And so the rigid body. So rigid body, we're going to be using, we're not going to use dynamic because Suzy doesn't jump or anything like that. So we're going to use kinematic. And then what we're also going to do is we're going to set on this useful kinematic. And we're going to change the collision detection to continuous and never sleep. And we're going to lock the rotation on the Z. The X and the Y we're going to leave open because we need Suzy to be able to travel up and down, left and right. Okay, so the sprite render is finished. The enemy controller, we're going to fill this in. So Suzy is worth 300 points, according to, if you look up on fandom. Maximum health is 5. Contact damage, I believe, is 4. When Mega Man touches Suzy, he gets 4 health taken away. There's no explosion damage. Bullets, none, because there is no bullets involved. The bonus ball color, we're going to default it to blue on this one. And then we're going to set the bonus ball type to the bonus type to random. And then the rest of this is fine. Audio clips, the only clip that we're going to be using is the damage clip. So in our audio sounds folder, it's going to be number 9 for enemy damage. It's going to go in the damage clip. The rest of this stuff, no bullet shoot position, no bullet prefab, but explode prefab. We're going to go into our prefabs folder under effects, and we're going to drag over the effect 1, which is our small explosion. And then down here, we're going to create the stuff for the script. So that's basically everything for the components except for the animator. So now we're going to work on the animator. So we're going to go over to the animations folder, and then we're going to go to enemies, and we're going to create a new folder there. And it's going to be called Adhering Suzy. And then we're going to go inside of it. Now in here, we're going to create, because we're going to have a base controller, the generic one, and then we're going to use two override controllers to control the color. So we're going to say create, and then we're going to do an animator controller. And we're just going to call it Adhering Suzy. And then we're going to create an override, which is going to be called Adhering Suzy Blue. And then we're going to create another override, and that one's going to be Adhering Suzy Red. So those are the overrides. So then we're going to have to create the animations. So the first animation we're going to create is a right click, create an animation. So Suzy has two states. It's going to be sleeping and waking. So we're going to just say Adhering Suzy Wake. Oops, take out that underscore there. And then another animation, which is going to be Adhering Suzy Sleep. So now we're going to tie these two animations to the controller. So we're going to double click on Adhering Suzy, the first one, and then we're going to have the wake as the default state. So we're going to go back over to the project tab, highlight wake, go back to the animator tab, right click, create state, and then from selected clip, then we're going to go back over to the project, select the sleep one, the sleep animation, and same process, and now we have both of them tied to the controller. So then we're going to bring in animations. So for the colors, so we're going to create one that says Adhering Suzy Sleep Blue, and then I'm just going to do Control D to duplicate that, and I'm going to say Sleep Red, and then I'm going to duplicate the blue again, but this one I'm going to say is Wake Blue, and then I'm going to Control D that, and then that one's going to be Wake Red. So now we have all of our animations there. Now the thing about this is these placeholders, this plain sleep, the generic sleep, and the generic wake, we're not going to do anything with those. But the blue, the red, we're going to change those. So the sample rate we're going to use for the eye opening and closing is going to be 16, and there's not going to be any loop time. It's just the animation is going to play out and then just stay on the last frame. So 16 for the red and 16s for the blues. So 16 on both the wake and the sleep. There. So then what we're going to do is on the blue override, we're going to drag on our Suzy generic controller, and then we're going to do the sleep blue, and then the wake blue, and those overrides. And then the same thing for the red, we're going to select the red, we're going to drag on the main controller, the generic controller, and then we're going to do sleep red, and then wake red. There. So if I bring this out, that's what it should look like for the red. Okay, so now to do the animations, or to drop the graphics or sprites in there, we're going to go to our Suzy, our actual game object Suzy, and then we're going to go to our controller for the animator here. We're going to drag on the override blue first. So there. Now we have this set up here. And for the wake, we're going to go over to the graphics folder. And then to wake up, we need to be in order 1, 2, and 3. So we're going to drag in 1, let's expand that so we can see 1, 2, and 3. So that's the wake up. Now to go to sleep, it's the opposite. It'll be 3, 2, 1. So to go to sleep, we're going to go 3, 2, and then 1. So that's the blue. So now we're going to go back over to Suzy again, and back to our animations enemy folder here. And now we're going to drag over the red override controller. So now we're going to set up the red sprites. We go to graphics. We're going to take, so this is the wake up, so we're going to go 1, so red 1, red 2, red 3 for wake up. And then we're going to switch it over to the sleep, and then we're going to go 3, red 3, red 2, red 1. So that's done. So those are our animations. And so then what we're going to do is we're going to go back over to our Suzy here, into our animations, enemy, and everything. And we're going to take that generic one, generic animator controller, just drop that in and replace it in the controller. So that is basically it for that part, but now we need to do the code. Alright, so switch over to the scripts enemies folder, and then you can open up your Adhering Suzy controller in a Visual Studio, or if you went onto the GitHub, you can just download the C# file, copy and paste the contents in your file. So we're going to go over the code now. So I'm not going to type this out, I'm just going to explain it. So here are all the components that we're going to have access to that are on our game object. We need an animator, the box collider. We have the rigid body, but we don't do anything with that really, so that's why it's grayed out. And then the sprite renderer, which is also grayed out, and then the enemy controller. So I have a bool here called is sleeping, so this is a flag whether Suzy's sleeping or not. This is Suzy's speed. This is a basically a variable that gets populated with the actual move speed, which is down here, so that we don't actually overwrite the original move speed. And then I have a sleep timer. And then, like I mentioned earlier, there's two methods for how I built into this how Suzy is going to stop movement. One is by detecting a collision with a layer by using a raycast. The other is actually just moving between points. So this is a vector 3 that's basically for the move to point. So this is like a stop point. So that's what this one is. And then in like the other enemies, I have a bool here that says enable AI. So this is basically a flag whether to have the enemy start using its logic or not. And this is something new that I'm probably going to be bringing into some of the other enemies, like Blaster, for instance. It's an option, or it's a bool called sleep on start. So maybe we don't want our enemy to start up and start doing stuff right away. Maybe we want them to sleep first before they do things. So like Suzy, so there's sometimes you see that there's delays with some of them. Like for instance, when you're in Bomb Man's level, you go up the ladder, and then all of a sudden there's 4 blasters there. You're going to notice that 2 of the blasters start, shooting bullets right away, but the other 2 aren't doing anything. And then after a certain delay, then the other 2, wake up, and then the other 2 go to sleep. So it's kind of like on, off, on, off. So what we're going to do is we're going to use the sleep on start for something like that. And then this is the move speed that Suzy will be moving across the screen. Approach speed is actually used for the collision detection. If Suzy moves too fast and you're using collision detection, it's a possibility that she'll travel into the layer. So what we do with the raycast is if the raycast is long enough, it'll detect ahead of time, and then it'll move to the slower speed, which is the approach speed, so that it doesn't fly past the collision and go into the wall. So it's kind of like a safety net. Raycast distance, this is how far the ray will travel out from when you're shooting it. So the higher this number, the longer the ray will be. And then the sleep delay. And then this is the stop position. So you're using this moving between the points. These are the points. So the way you're going to want to use it is index of 0. If you're using horizontal movement, so left, you want the value for left to be index 0 and the value for right to be index 1. And if you're using vertical movement, then you're going to want the index 0 to be for the up, and then the down will be index 1. And then here are some enums. We have movements, so 2 movements, either horizontal or vertical. I'm going to default to horizontal. And then the directions, so if you're horizontal, you can either go left and right, or if you're going vertical, it's either up and down. Now, the numeric value of each of these is an index into this direction vector down here. So that's why the left is the first one, right is the second. So they have to match up. Because what we do is when we take our integer value of this, we're going to index this to get which vector direction we're going to be traveling. And then we have our stop methods. Two types of methods. We're going to stop based on either collisions, or we're going to just move between positions or points. By default, I set it to use collisions. And then down here we have the colors, blue and red. We're going to default to blue. And the runtime, the override controllers for blue and red. In the awake, we just get the handles to our objects, our components. And then down here in the start, we're going to start with whatever the value of sleep on start is and set that to sleeping. So if it happens to be that Susie is sleeping, we're going to set the animator speed to 0. If Susie is not sleeping, then we're going to start the animator speed to 1 so the animations will start playing. Susie speeds will be initialized to the move speed. Set the sleep delay, and update move positions has to do with updating the points with the movement. So we just call this, all the time, whether we use collision or not, so we don't have to check. And if it is true, then we'll just do it anyway. And then set color, whatever the color is. So in fixed update here, what we're going to do is we're going to see if the move speed is greater than the approach speed. So if it is, then we're going to see, we're going to check for the collision with the ground layer. We're going to get the center of our box collider, and we're going to set that as the origin. And then the index, or the integer value of our direction, will be used to pull out the direction vector that we're going to use for our raycast direction. And then with our raycaster, we're going to populate it with the origin, the direction of the raycast, the length of the raycast, or the distance, and what layer we want to collide with. And then we're going to see if we hit it, if we hit that layer, and if we did hit it, then we're going to change our Susie speed to our approach speed. And then we're going to just do a little draw ray here, just to see the ray come out of Susie, and we'll just set it to magenta. And then down here in our update loop, we're going to freeze the enemy. And then down here, if the AI is enabled, then we're going to do the logic. First, we're going to see, is Susie sleeping? If Susie's sleeping, we're going to count down on our sleep timer, and once the time is up, then we're going to tell Susie, hey, time to wake up. But if Susie is not sleeping, then what we're going to do, Susie must needs to start moving. So we're going to check the stop method. Is the stop method equal to collision? If it's equal to collision, all we're going to do is change the transform's position. So to do that, we're just going to take the speed that Susie set at. We're going to take that integer index of the direction that we're moving to pull out the vector, times that by the speed, and times it by time.delta time. So that'll get Susie moving, either left or right, or up or down. But if it's not collision and we're using actually the position collision, well, it's not really collision, but position stop method, what we're going to do is instead we're going to use vector 3 and move towards. We're going to take our position and we're going to set that as the first parameter, and then we're going to see what our stop position is. So we want our position to keep moving towards the stop position at speed times delta time. And then once that transform position is equal to the stop position, that's when we're going to tell Susie to go to sleep. Now, this part about the collision, Susie goes to sleep on down here on the collision enter 2D. So if Susie hits that ground layer, or that layer that you're being checking for, that's when this gets triggered. So we're only going to want this stuff to get executed if we're using the collision method. So if it's the collision method and the layer that we're intersecting with is the ground layer, in this case I'm only using the ground layer, then we're going to tell Susie to go to sleep down here. But up here, it's done through after the transform position is equal to the stop position. And then we have down here two functions. I got to wake and I got to sleep. So when Susie wakes up, we're going to just say is sleeping was false. We're going to set the animator speed equal to 1, and then we're going to play the wake up animation, which is basically the eye opening up. And then in the sleep, we're going to say sleeping is true. We're going to reset the sleep timer. The Suzy speed is going to be reset to the move speed in case the approach speed got overridden by the approach speed. We're going to get the next direction, which is down here. We'll go over in a sec. And we're going to update the move positions, which has to do with the stop position. And whether we use that or not, doesn't matter. We're going to just update it anyway. And then we're going to play the Suzy sleep, which is the eyeball closing. Now down here on the get next direction, and I tried to shorthand this as much as I could, so if the movement is equal to horizontal, this line will be executed, but if it's not, then this line will be executed. So assuming it's horizontal, we're going to see, is the direction equal to left? If it's equal to left, we want to make it right. But if it's equal to right, then we want to make it left. And if it happens to be that we're doing vertical, then we run this line here. And if the direction happens to be up, we want to change it to down. And if it happens to be down, we want to change it to up. So we're just basically toggling, whichever direction we're going to be switching to. Now down here, we're going to do the update the stop position. So we're going to check and see if the stop position is equal to horizontal, then we'll do this line. If it's not, then we'll do this line. So if the direction is equal to left, then as we know the index up there, we want left in 0 and the right in 1, or up in 0 and up in 1, or right or down in 1. So if it's equal to left, then we want to get that left position. But if it's equal to right, then we want the index of 1, that position. And then if it happens to be that we're going vertical movement, then we want up to be index of 0 and down happens to be index of 1. So we're just taking whatever and we're going to fill it into that stop position because that's going to be the next place it's going to stop. And then down here is just a bunch of publics I have so that you can basically program Suzy through code in real time if you need to, like turn on the AI on and off, set the color. Here you have the animator controller to override. So once you change the color, call this, and then it'll change the animator controller accordingly. And then if you want to sleep on start, you can turn it on or off. Update the move speed, change the approach speed, change the raycast distance, change the sleep delay, update the stop positions, P0, P1, and then change the movement from horizontal or vertical, change the direction depending you want up, down, left, right, up, etc. And then stop methods if you want to do the collision or if you want to do the position. So that's basically Suzy in a nutshell. So that's the code. And if we go back over here, now if we go back to the Suzy here and go back to the bottom, sec. Let's remove it because I changed the script. So we're going to remove that, drag it back on there. There we go. So there's all the stuff. So now what you need to do, these are all the defaults we have set up, but we have to tie in the controller overrides. So if you go back over to your animations in Suzy, what you're going to do is you're going to put the blue one, blue override, and the red override. And so that's basically your Suzy. Your Suzy is done. So now all you got to do is create a game object of it. So then you're going to go into your prefabs enemies, and I'm just going to change that over to that, and I'm going to drag Suzy in there. So there, now I have a prefab of Suzy. Okay, so what we're going to do then is we're going to add in, we're going to duplicate Suzy, Control D. So we're going to add 3 of them into the scene. The one that's moving between the 2 broken highway pieces. We're going to have the one at the bottom of the highway and the one moving between the crates. So we're just going to rename those. So our first Suzy is going to go, let's stretch this out so we can look at the scene. So the first one's going to go up over here. So these positions I already have set, so we're going to do on the first one, the X is going to be negative 15.308, and then the Y is going to be 4.05, and then this one's going to be red, so it's not like we can really shoot it, but we're going to give it a red bonus ball. And then what we're going to do down here is we're going to turn on the AI. This one's going to start sleeping when the scene starts. And leave the move speed at 1.5, the approach speed 0.05. These are going to stay as defaults, and we're going to change the color to red. Now the second one, we're going to put down here. There you are. All right, so the second Susie is going to be at negative 2.214, and the Y is going to be negative 0.638, and this one is going to remain blue, so we'll just keep it with the blue ball. And we're going to turn on the AI. We're going to not let it sleep on start. We're going to let it wake up right away. We're going to change the speed though to 1. It's a little bit slower. And these rest of these are default. It's fine. However, the movement we're going to change to vertical. The direction we're going to change to go upward. Leave it on collision. Leave it on blue. So that one's done. The next one we're going to put over here between these two crates. So let's just pick the third one. Now the location for that one is going to be 4.7234 on the X, and the Y is going to be negative 0.902. And the rest of this is fine, except when we get down to the Suzy controller. So we're going to turn on the AI. We're going to just set it to sleep. We're going to change the move speed hour to 3. Since we're going to be using the position stop method, so this approach speed and this raycast distance, they're going to basically be ignored. So we don't have to worry about those. However, what we're going to do here is we're going to collapse this stop positions, and we got to give it which points we want it to basically move between. So first point is going to be the left. Index 0 should be the left. So that's going to be 1.845. And then the Y is going to be the same Y that we're at right now, which is going to be 0.902 negative. I'm going to copy that. I'm going to paste that there. And then on this first one is going to be where we're at right now, so it's 4.7234. And that's going to be horizontal movement. We're going to move left. Our stop method is going to be position though, and that's the rest of this is fine. So with that done, we're going to go in here. Now before we start it up, let me just save my changes. Now before we start it up, there's one more thing that we're going to change, and it actually has to do with the enemy controller and a couple other files. So let's go into the enemy controller. So in the enemy controller, we have enemies can be frozen. We have a freeze method. So when they're frozen, their animations stop, and when they're unfrozen, if their animations should play back up. Well, the way I wrote it originally is basically when it's frozen, stop the animation. When it starts back up, play the animation. Well, there are cases where the animation might not even be running when you freeze the enemy. So this just assumes that it's running, just stop it, and then to start it back up. Well, that might not be the case. Suzy, for instance, may be sleeping on start, so we don't want the animation to start up when it's sleeping. So we need to remedy that. And to do that, what we're going to do is we're going to bring in a new float here called animator speed. And this variable is basically going to capture whatever the current speed is set when it's frozen, and it's going to restore it to that value. It's kind of like what we did with the color and the freeze velocity and things like that. So we're going to send that over. And then down here in our freeze enemy, we're going to send this over. So we're going to capture the current animator speed and store it in that variable. And then we're going to set the speed then to 0, because now we know what it was originally. And then we're going to restore it back to whatever the speed was that we captured when we unfreeze the enemy. So we're going to save that. And just because we're doing it there, we need to do it. We're going to just do it in these, even though they're not really have to do with the enemy. If you have an animated bullet, it's the same thing. So we're going to send over. So this is in the bullet script. So we're going to add in an animator speed float, and then down here we're going to send over to capture it and to restore it. And then the last one will be the explosion. So we're going to send that over, and then we're going to send that over, and then we're going to send that over. So we're going to save that. And now if we go back over to Unity, we'll let it finish its crunching. And then we're going to try this out. Well, let's play it. And ignore that. It has nothing to do with the script. It has to do with something else. So here's our Susie. If we zoom in, there's the raycast in magenta that's being projected out. It's going to collide with the ground layer that's here and here. And once it approaches, it's going to stop there. And then as you can see the animation, when it starts moving, the eye opens, and then when it stops, the eye closes. So it plays both animations of wake and sleep. So that's the first one. So let's go and check out our second one that's moving vertically. Actually, let me just move this here. While I get down there, you can watch it while I'm moving on the right. Alright, so here's our Susie here. So our Susie's moving up and down. There's the raycast projecting out. So let's choose this one. Let's just speed it up and see what happens. So let's say move speed is 2. So far so good. It doesn't get into the ground, but if we speed it up with a small raycast distance, it will eventually fly into past our on collision. So let's say 4. And you see it went overboard. It's doing it there. See, to remedy that, we would increase our raycast distance. And then what you'll notice here also is as it gets close, you'll see it slows down so it doesn't go past it. So that's the little bit of a drawback with that method. You don't want it to fly past it, but you got to see when you're about to hit it, but you got to slow down so you still don't go past it. So that's the collision method. So now we're going to go check out this other one. So this is the point-to-point method. So I'm going to pause this where I'm going to get here. Boom. Now you can see this is perfect. This is precise, right on the line. And so I'm going to pause it over there. We can check out the other side. Now you can see right on the line. So now I'm going to speed it up. Let's move it to 6, for instance, double speed. You see how fast it's moving? Now let's take a look again. Precise. It was itty bitty smidgen right there, but still precise. And we're going to let it go to the other side. Pause it there. Precise. So now what we're going to do is we're going to check. So we know our left is supposed to be x of negative, or 1.845, and our right is 4.7234. So what does it say there? 4.7234. So now let's go check the other side. Stop it. So what do we say, 1.8345 or 1.845? 1.845. So it's a lot more precise in when it's hitting or when it needs to stop or adhere to wherever you want it to adhere to. And I like this method because also these crates, they don't have a ground layer. So there's no layer that this guy is checking to see if he needs to sit on it or not or detect it. So you can actually have a move between anything, up and down, left, right. You just move between 2 points. And then you can have them go as fast as you want or as slow as you want. It's up to you. So anyway, that brings us to the end. So that's creating Adhering Suzy, aka Octo Battery. So if you found this tutorial useful or you learned anything, give it a thumbs up. I always appreciate that. If you haven't subscribed, then subscribe to the channel. We're building Mega Man little by little. We're not making a fan game. Well, you can, but I'm not. I'm just building out the little pieces, and I'll have I'm going to recreate the Bomb Man level at the end of the series. So this is one enemy closer to that. There's one more to go, and then I'll have all the enemies for that level. And then we're going to get into tile maps and ladder climbing and checkpoints. And then we're going to build the last level, and then that's where I'm going to say series is over. So anyway, have a good day. Stay safe out there. I will catch you at the next video. Bye.